homework. Again, sometimes I'm going to collect this stuff, sometimes I might not. If you are still doing the homework for points and you have completely missed the whole talk about being authentic, the reason that we are doing homework is not for grades anymore. It's to understand content. So I'm going to go over the stuff that you did last night. And like I said, sometimes I'm going to collect it, sometimes I'm not going to. Depends on what I need to get done, but I'm still going to go over it. So here we go. You're supposed to be, correct?
Yes.
What do they have in common? Only an x, right? And then I'm left with x squared minus x minus 20. X. I can double bubble right away because this has a square root, but that doesn't. So it's not a special case. I already pulled out a greatest common factor, so I've already done that step. So now I'm on to A. A is 1. Thank you so much. Two numbers that multiply to 20, but are different signs, so they're going to subtract from each other, and they have to subtract to a 1. X, 5, X, 4. And I need the negative to be the bigger number. So 5 is bigger, so I need it to be the negative and the positive to be there. Following with what I did. What are my roots from this? X equals 0 is from right here. X equals 5. And x equals negative 4. So I look at this. Negative 4. Boom. 0. 5. And it is positive and odd, so I know my end behavior is down and then ends up. So down, ends up would be a sketch of that graph. Does that consist with what we've talked about for an odd thing? Yes. Does it consist where we have two extremas? Yes, because something to the third power can have two extremas or 0 extremas. Follow me. We did C in class. Let's go ahead and just jump to E, and I think that should be enough review for that. What do they have in common? Is a 10. What am I left with? Is x squared minus 5x minus 6. 10. Double bubble right away. This has a square root. This doesn't, so it's not a perfect square case. You with me? Then I need two numbers that multiply to 6, but subtract to a 5. Don't forget the most basic way to get to 6, which is 1 times 6, because 6 minus 1 is the 5 that I need there. Some kids are going to think 2 and 3, because they're going to add. Are you following me? But what does this sign tell me I'm supposed to be doing with those two numbers? And 3 minus 2 is 1. It will not work out if you put a 3 and a 2 there. Are you following me? They love to pick examples like that. They love to pick examples where there's two numbers that get me to 6, but add to 5, and two numbers that get to 6, but subtract to 5. Because they want to know if you truly understand how to factor. Alright, so this doesn't work. So it would be a, remember the bigger number is going to be negative, so I need a 6 and a 1. And it's going to be negative 6 and a positive 1. And again, you can redistribute that back out to make sure it works. X times x is x squared. Check. X times this is a positive x. This times this is a negative 6x. When I combine those, check, it gets me a negative 5x. And a negative 6 times a positive 1 gets me to a negative 6, which is what I needed. Following me? Does this have a root out here? It's just a constant, right? There's no way to make this a 0. Not by changing x to make this by itself 0. Are you following me? How many roots should this problem have? How do I know that? Squared. So x equals 6 is one of my roots. X equals negative 1. And remember, those are 6, comma 0, negative 1, comma 0. Those are my roots. When I'm in my root, I know that my y is always going to be 0. I'm on the x-axis. So 6, negative 1. I know that this is a parabola. I know that it's a positive and it's even, so I know it starts up and ends up. And I know my vertex is somewhere in the center here, so I'm just going to go like that. Because they just asked me to draw a quick sketch. Now, technically, if they asked me to draw this much better, if they asked me to actually graph this out, I could find my roots, like I did. That would work out. What else can I do to find my, let's say they actually want my vertex and my roots. What form is this still in from chapter 2? Standard. How do I find my vertex in standard form? Opposite of, over. That gets me my x coordinate of the vertex. I then plug that x in, and I can find my y coordinate of my vertex. Yes? Always trying to review and keep you guys, familiar with the stuff we've gone over. So one thing you guys got to understand is that this is not going to go away. This is material that's going to be on your PERT test that you're going to take very soon. It's going to be on your SATs. It's going to be on your ACTs. In fact, Algebra 2 is probably one of the heavy hitters because it tests all of your Algebra 1 skills and all those. So they can test more than just Algebra 2. They can make sure you know your Algebra 1 at the same time. Okay, so Algebra 2 is going to be one of the biggest hitters on those standardized tests. So that's why I keep going over it, because this is not a class where you can kind of just know it for now and move on and be successful later on. Are you following me? Okay, we've got to know this authentically. That's why I keep asking you to study a little harder than you normally do. All right, we did this yesterday. I asked you to try this one, right, by chunking. All right, let's do that one real quick. What number am I going to want to use? Or what am I going to want to make c equal to? Let's see. 7x. And why does this? Remember, chunking is only going to be a special case. It's another kind of special case because I need this z to be able to make, oh, look, that really is 7x times 7x, which I can rewrite as z times z, which I can write as z squared. Are you following me? Plus, how many times does 7x go into 35? So I need 5 z's plus 6. Now I factor my double bubble way. Z, C, two numbers that multiply to 6, but this time add to 5. And they're both going to be positives. So plus 3, plus 2. Right, Joel? And then I go and I replace my z's and I make them 7x plus 3 and 7x plus 2. And there would be my two factors. All right. Now we get to some new stuff. This type should not be too new. Do you remember when we did when A wasn't 1, and we did the first number times the last number, and then we ended up with 4 terms in the middle? Do you remember? We ended up with like an x squared plus 5x plus 3x minus 7 or something. Remember when we turned the middle term into 2 different ones? And I said, remember, put parentheses in here and do that? Well, this one won't work out, so don't worry about it. I just made that up quickly. But the same process is going to happen here. Look, do you see how we start off with 4 terms? That's going to be a huge hint that you're going to graph by grouping. Remember, you need hints onto how you know when you're going to do this. Well, here is a big hint, is you're starting off with 4 terms. Notice what Colt did down here. They don't, I think this book does not a very good job of explaining this problem, especially with Colt right here. So he needs to pick up his game. He groups this together. Now, what did I tell you about if there's a negative here? Kick it inside the parentheses and put what out here? You have to put a plus sign out there, or else what does it look like these two bubbles are doing now? And they're not. I can't change subtraction to multiplication, but I can change subtraction to addition of the opposite, which is what I just did. Are you following me? Now, he goes, what does this bubble have in common? And he says x squared. And when he factors out an x squared, he's left with x plus 3. Is everybody okay with that first step? Now, watch what happens here. I can cheat. Remember what had to happen is the first bubble, the second bubble had to be the same. So I can cheat. I know I want my first bubble or my second bubble to be turned into an x plus 3. So I can kind of help me. And if that's not happening, then I didn't pull out the greatest common factor up here. Something messed up. Because you're going to have to get the same thing here as you do here, just like Colt did. So here's how I cheat, especially on a problem like this. What does this say? Negative x. What does this say? Minus 3, right? Well, if I look at that, isn't it almost what I need? Except the x is a negative. It should be a positive. And the 3 is a negative. And it should be a... So when all my signs are just mixed up, what number can I use to change signs but not change values? And so he factored out a negative 1. Because negative 1 times x goes back to a negative x. Negative 1 times a positive 3 is a... So have I changed the value or just the way it looks? And now did I end up with an x plus 3 and an x plus 3? Now here's the other thing you need to be able to see. Do you see this subtraction sign? It's separating a number here and a number here. What does this number have in common? And I want it to. It has to have in common. What do they both have in common? So I pull out their x plus 3 that they have in common. It's a greatest common factor problem again. I say, hey, you have an x plus 3 and you have an x plus 3. Let's pull that out and share that one. And what if I multiply by what's left over? What's left over in this bubble? X squared. What's left over in this bubble? Minus 1. Do you see where the x squared and the minus 1 came from? Now he's not done again. Because he realizes, I can't factor this anymore, can I? But I can factor this guy. What kind of problem did that turn into? Say louder. It turned into a difference of squares. How did Emily recognize that? She said, hey, does this have a square root? Yes. Does this have a square root? Yes. The square root of 1 is 1. Is that a subtraction sign there? Then I just do x plus 1, x minus 1. Difference of squares. They look exactly the same, except one's plus and one is minus. That's the difference part. Remember us going over that.
Copy card.
Thank you. Does everybody understand these steps? Yes? All right. Go ahead and try this one for homework. Maybe I collect it. Maybe I don't. But again, we're not doing this. For the... All right, here we go. This is a new concept, something that they're talking about. We should be able to pick this up pretty easy. Okay, Braxton again did this. Okay, he bubbled here. Does he have to put the plus sign in the second bubble on this one? No, it's okay. Whenever there's not a negative there, it's not such a pain in the butt. Whenever there's a negative on that second one, it becomes a pain in the butt. Let me go back here and see how smart you are. Let's say I don't want to do all that negative garbage. How could I fix... never mind. It wouldn't work out. Not for that one. Never mind. Alright, so here we go. What did he have in common? X squared. He pulled that out. Does everybody see why I got an x plus 2 left? What do they have in common? A 4. Pull that out, And again, my first bubble and my second bubble are the same. That has to happen. He pulls out an x plus 2. Now, normally, here's how I write it. Normally, I say, what do we pull out? X plus 2. What am I left with? X squared plus 4. Now, does it matter if this bubble comes second? No, because that's, again, the commutative property. And I try to keep talking about these vocab words so we can use them. You guys following me? All right, so now watch. This is he's done. He's correct. You see, they gave him the thumbs up. Remember in this book, they tell you what's right and what's wrong with the thumbs up. Now, Kenny did this a little bit farther. Kenny took this a step farther, and here's the new part. Do you see they do the same thing, but when they get here, Kenny breaks this down. Here's what I want to show you. Remember, if I'm finding, which these are called factors, factors help me find my roots. Roots are when these bubbles equal what?
0.
So couldn't I take x squared plus 4 and set it equal to 0? Now, watch what pops out. Watch why I taught you something in chapter, I think it was 3 that we did these. No, chapter 2, I guess. What happens when I minus 4? I minus 4. I get x squared equals a negative 4. How do I undo squaring something? Square root. Who put the square root sign in there? So what do you have to put on the other side? Plus or minus symbol, because you put the square root in there. What happens when you have a negative under a square root? What pops out? I. What's the square root of 4?
2.
Do you see how he got to factor this into 2i positive and a 2i negative? You with me? Now, here's what happens, so be careful of this. When he goes to put the positive 2i into the root, which one of these, this is the root, which one of these factors belongs to that one? The first bubble or the second bubble? The second bubble, because remember, it's when I plug this in into here, it makes it what? So I know you guys think that this one actually belongs to this one, but it doesn't. Remember, when you put it back in the bubbles, you have to do the opposite. Are you following me? Okay? So if I gave you this, let's pretend you had this. Make that a square, not a cube. Doesn't it look like a difference of squares problem?
Yeah.
This has a what? This has a what? But there's a what here? You couldn't. Why couldn't you factor this before you got to this class? What numbers had you never heard of? Imaginary. Now why can we teach you how to factor this? Because you've talked about imaginaries. And so what would be my factors? Would be x plus 3i and x minus 3i. You with me? I don't hear this all. Imagine. Brendan?
Yeah.
There we go. All right. What set of numbers was Braxton? Because he still got the question right. What would the teacher have asked you if you were going to factor it like this? What is he only factoring it over? What number system? The reals. What did Kenny take it to? So that's how they're both correct. It depends on what you're trying to factor over. Does that make sense? If you're factoring over the reals, you can stop here and be done. If you're factoring over all numbers or including imaginaries, you need to go all the way to there. Will these guys show up on my graph? No. So how many times will this thing right here intersect the x-axis? So how many, what's in behavior? Down and then up. Yes? How many times do we say it's going to intersect the x-axis? Once. How many turns will it have then? How many extremas would it have? Probably, well, I guess we can't answer that until we draw the picture. Because here's what I know will happen. It could look like this, where it only hits once, right? Or if it does have some extremas, the extremas have to do this. Where the extremas are happening like that, those extremas can't happen near this x-axis, or what? I'd have more roots. Are you following me? So I know the extremas are going to happen up or down below. But they won't be able to happen near the x-axis.
Couldn't you also have kind of like a straight line?
Like this. Alright. Now this guy, I want you to pretend like this is just x squared. Pretend like this is just x squared. And you are going to factor it like it's x squared. But if I have x to the fourth here, don't you see I'm going to need an x squared times an x squared in order to pump it up to an x to the fourth? But do you see, here's what I mean. What does this tell me if this was like I have done before? Same signs and I need to add. You with me? Both signs are going to be negative. I need two numbers that multiply to 100, but add to, isn't that what they got down here? And the only difference is instead of putting an x here, we put an x. And then you have to look at these guys and say, hey, can I factor them any further? Can I go any farther with these guys? And yes, you can. This is a difference of squares problem. Right? This has a square root subtraction. X minus 2, x plus 2. This is a difference of squares problem. X minus 5, x plus 5. You following me?
Wait, so with like the imaginary numbers, if it was like x squared plus 4,
you would, yep. Try these two for homework. Alright, so these, they ask you to factor it. Let's see if we understand some stuff. Because they gave me this graph, what does this give me right here? The root. What's the root? My root is 2. What would that look like as a factor? Does everybody see? I know that x minus 2 is a factor of this. X minus 2 times something would get me to this. Well, how do I figure out what this something is? What did I teach you in the last couple sections? How can we do division? Long division or what? So couldn't I do synthetic division to get my other bubble over here? Meaning I go, okay, my root is 2. I know I've got 1, 0, 0, negative 8. And it should go into it perfectly, correct? 1, bring that down, I get a. Bring it down, I get a 1. 1 times 2 is 2. Add them together, you get 2. 2 times 2 is 4. Add those together, you get 4. 4 times 2 is 8. Add those together, you get a 0, like I should. That's my remainder. You bring it straight down, right here. What's the coefficient in front of that? A 1. What am I left with? Remember, this always starts with 1 minus that. That was x to the third. So what's this going to start with? So it's x squared plus 2x plus 4. Now, how do I know I'm not going to be able to factor that anymore across the real numbers? I'm not going to be able to factor this any farther. If I wanted the root, I would have to use the quadratic. I know it's going to be imaginary. Why? How many times does this thing touch the x-axis?
Once.
If it was more factorable, I would have had more x-intercepts. But since I don't, the only way that can happen is if these guys from this equation would be what? What kind of numbers won't show up on my graph? Imaginary. So the roots from here are going to be imaginary, and I'd have to use the quadratic to find those roots. How do I know that? Because I can see a picture and there's only one x-intercept. So I know this is not factorable. Are you following me? Same kind of thing can happen here, except they don't give me a graph. What do they give me? An X and Y chart. Where is my root? What does Y equal when I'm at my root? What does Y equal when I'm at my root, no matter what? Y is 0. Are you with me? So what does that mean my root is? -3 is my root. What would be my bubble? And then I can use long division to figure out what the other part is. You following me? Alright, now we need to get to these guys. They show you why this happens. They show you how there's a pattern of this. Okay? I'm just going to go straight to what happens. There should be 2 of these. Yeah. No, they don't. Alright, right here. I don't know why they don't do this. If something can be written as something cubed minus something cubed. Remember how we had difference of squares? It was something squared minus something that had a square root. You with me? So if I wanted to rewrite this as like, they would write this as a squared minus b squared. What would my a be for this question? No. Something squared. What would be squared? X. What would be they were referring to for b? Not 4. 2, because 2 squared. So this would be, are you following me? Okay, so when they say this, they're looking for something cubed minus something cubed. So it turns into this form where you just do this every single time. You put the a here, you put the b here, you square a, put it here, times a times b, and put b squared. Just doing one of these examples is going to be a lot more, help you understand it a lot more. So if I had this. Now, is this written as a cube? So what is a in this example? X is my a. Are you following me for what they're talking about over here? Is this written as something cubed? Can it be written as something cubed? What can this be written as? So what is my b in this question? 2. Just 2. Do you see what I'm talking about? Now, do you see I write this? X minus 2. A minus B. I need to figure out what A was. I need to figure out what B was. I came up with an example. Now, what is A squared going to be? What is A? So I'm just going to, and then A times B would be, and then B squared is going to be, because 2 squared is 4. That's how you factor them. A times B.
Oh, okay.
A times B. Now, the other form looks like this. The other form is almost identical. If you have A cubed plus B cubed, it equals this. Now watch how you can tell that this is how I remembered it. What was my sign here? So what went in my first bubble? And everything else after became positive, right? What was my heat? What was here? What was in my first bubble? And then what was right here? Now, why does this have to be plus no matter what? Come on, someone have some kind of going, ding! We've been talking about this idea. B is what? What are you doing to B? So even if I put a negative number back there, what does it turn into? Does that make sense?
Oh, yeah.
You with me? So, let me make sure on that. Alright, so that means like, even if I gave you that other example, like, so, let's try another one. x cubed plus 27. Do I really care about the 27? What do I need it written as? Something what? So I can find my a and I can find my b. Are you with me? So x cubed, I can rewrite this as 3 cubed. Why? Because now I know my a is really x, and I know my b is really 3. And then I just plug in down here. So it becomes x plus 3, yes? And then x squared minus 3x plus 9. Making sense? Yes? Now be careful because I'm just giving you easy ones, but even if you have something up here, like technically you could have this. Technically you could have this. I need this whole thing to be written as something cubed, don't I? So what could it be? What is my a for this question? My a is actually not just x this time. It's what? 2x. Do you see how if I cube this, this gets me to 8, and I cube that, it gets me to x cubed. So it's equivalent. Remember, changing the way things look, but not their value. Minus 4 cubed. You with me? So now I've got my a, and I've got my b, and I just plug in using whichever one of those formulas it fits. Which would have been the first one. Yes? All right, last thing. We've already done this. Difference of squares. You should be able to crush this. Right here, let's go through it real quick. What's the difference of squares going to be? X plus 8, x minus 8. What's the square root of this one? Now it's not, it's x to the 4th, right? So it's x squared minus 4x squared plus 4. If I'm factoring over the real number system, can this one be factored anymore? Yes, it's a difference of squares. Can this one be factored anymore over the real numbers? No, because this one would turn into what? Imaginary. So I can leave this one alone, but this one I have to make x minus 2, x plus 2, and this one I can leave as x squared plus 4. How many real roots is this thing going to have? 2 real roots, 1 and 2. And then these guys are going to kick me back to imaginaries. Are you following me? I'm telling you, it's all going to come full circle the more we go through it. That's why it's so vital to understand all this stuff. This is a perfect square. Remember I told you the way to check this. I'm just going to go through this last part and then we'll be finished. Remember, you take the square root of this guy. Square root of this guy is 4x. Square root of this guy is 10. You are supposed to multiply them together, which gets me to 40x. And then what? Double it. Double it. If I double it, does that get me this? This is not a perfect square. You can't factor it using that. It won't work. You'd have to do a different way of trying to factor it. Check this guy out. What's the square root of this? X squared. What's the square root of this? 7. But here's the big problem. If it's going to be perfect squares, they're going to have to be the same signs, right? What is this sign back here? Which means that they are different signs. Not an example of a perfect square. Hopefully they give us one that actually works. This one works. What's the square root of this? 3x squared. What's the square root of this?
1.
This times this is 3x squared. Doubled it. Does that get me this? then this is an example of a perfect square. And the way you factor that is 3x squared plus 1 squared. How did I know it was a plus right here? Not because of this guy, because of this guy. We've done perfect squares in class. We did those. That's just a recap to kind of help you out. Yes? Thank you. I know it's long.